Digital camera figure is shown in figure. Now let us understand the working process of a digital camera using the figure shown in this slide. Although the internal design of different cameras may vary, the basic working principle remains almost the same. The first component is the camera lens. The lens collects light reflected from an object and focuses it accurately onto the image sensor. The quality of the lens directly affects the sharpness and clarity of photograph. A high quality lens captures more light and produces better images even under low light conditions. Next is aperture, which controls the amount of light entering the camera. We can compare it to the pupil of the human eye. In bright sunlight, the pupil becomes smaller to reduce light entering the eye, while in darkness it becomes larger to allow more light. Similarly, the aperture automatically adjusts depending on the lighting conditions. The next important component is shutter. The shutter opens for a very short duration, allowing the light to fall on the image sensor. If the shutter remains open longer, more light reaches the sensor, making the image brighter. If it opens only briefly, less light enters, producing a darker image but allowing fast moving objects to be captured without blur. Once the light reaches the image sensor, millions of tiny pixels begin collecting light information. Each pixel measures the intensity and color of the incoming light and converts it into an electrical signal. Those electrical signals are then sent to the image processing unit, sometimes called the digital signal processor or DSP. This processor is one of the smartest part of camera. The processor performs several operations automatically. It adjusts brightness, improves contrast, corrects colors, reduces image noise, sharpens the image, and compresses the image into a digital format such as JPEG or RAW. The processed image is then stored in a camera's memory card such as an SD card or micro SD card. Because everything is stored digitally, thousands of photographs can be stored on a single memory card. Finally, the captured image is immediately displayed on the LCD or LED display screen, allowing the user to review the photograph instantly. This instant preview is one of the biggest advantages of digital cameras over traditional film cameras. If the image is blurred or not properly exposed, it can simply be deleted and captured again without any additional cost. This complete process from capturing light to storing the image takes only a fraction of a second in modern digital cameras. Next, we'll see the applications and advantages of digital camera before moving to the camcorder. Now let us discuss the applications of digital cameras and advantages of digital cameras. Digital cameras have become an essential part of our daily lives. They are no longer limited to professional photographers. Today, almost every smartphone contains a high-quality digital camera, allowing people to capture photographs and videos everywhere, every time, and anywhere, anytime. Digital cameras are extensively used in journalism for reporting news events quickly. They are widely used in wildlife photography, where photographers capture animals from long distances using telephoto lenses. In the field of medicine, specialized digital cameras are used in endoscopy, microscopy, and medical imaging to assist doctors in diagnosis. Digital cameras are also used in scientific research, satellite imaging, astronomy, industrial inspection, robotics, and machine vision systems. In security surveillance, digital cameras are continuously used to monitor banks, shopping malls, airports, railway stations, hospitals, and educational institutions through CCTV systems. They also play a vital role in online education, video conferencing, biometric systems, facial recognition technology. Now, let us summarize the major advantages. The first advantage is instant image preview. Unlike film cameras, there is no need to wait for a film development. Second, digital camera provide high resolution image, allowing photographers to be enlarged without significant loss of quality. Another important advantage is that images can be edited easily using computer software before printing or sharing. Digital photographs can be copied, stored, transferred and shared through internet within a few seconds. Modern cameras also provide advanced features such as autofocus, image stabilization, face detection, HDR imaging, panoramic photography and artificial intelligence-based scene recognition. Storage is another major advantage. Instead of carrying multiple film rolls, a single memory card can store thousands of photographs and several hours of high-definition video. Because of these features, digital cameras have completely transformed photography and have become indispensable in modern entertainment electronics. So far we have studied how a digital camera captures still images using image sensors and stores them in digital format. However, many situations require not only photographs but also continuous recording of video along with sound. So for this we use another important device known as camcorder. So the word camcorder comes from combining the two words camera and recorder. How a camcorder works is by recording audio and video, then saving those to a digital storage device, thereby creating your own movies or videos and capturing life on video. So this is what we need to know a basic about camcorder. So it is closely related with digital camera. In the next section we will see in detail about, we will study the construction of camcorder, working principle of camcorder and the basic block diagrams of a camcorder and features of a camcorder and applications of camcorder and the use cases of camcorder, like what we have seen for digital camera, what are the different fields at present camcorder is used, and what are the major advantages compared to digital camera and the disadvantages of this camcorder compared to digital camera. So all these things we will discuss in the next lecture. So thank you for watching this lecture.